Hi guys, so we're going to look at the triangle inequality and the Pythagorean theorems today. So we're going to look at what are the different lengths of a triangle can we have. Alright, so our triangle inequality theorem. Do any three numbers make a triangle? So what we're going to look at first is these three examples. Do these three examples make, or four examples, sorry, make the sides of a triangle? Okay, so I'm going to go over here. I'm going to start with 10, 3, and 5. Okay, now if I look, no matter what I do, no matter how close I try and get them, my sides, my B, will never match each other. Okay, so 10, 3, and 5 don't make a triangle. Now what if I look at 12, 4, and 9? Okay, notice how when I move my B, I can get them to match up. Okay, so 12, and I know they're not quite matching, it's just the program here, but 12, 4, and 9 make the sides of a triangle. Okay, now we're going to do one more. I'm going to skip the third one, 2, 4, and 5, and I'm going to go down to 3, 5, and 8. So 8, 3, and 5. All right, so this one's going to require a little bit more finesse here. We're going to zoom in a little bit, and I'm just trying to get my B to match. Oh boy. Okay, and you'll notice that no matter what I do, they don't match until they're on the line. And that's no longer a triangle, right? Okay, a line is not a triangle. So 3, 5, and 8 don't work either to make a triangle. Okay, now I'm going to give you the answer for number 3. 2, 4, and 5, they make a triangle. So these two made a triangle, while these two didn't. Okay? And it's not a guessing game. If we look at your two smaller numbers. What happens when I look at my two smaller numbers and compare it to my bigger number? You'll notice in the first one, my two smaller numbers don't add up to that bigger number. Or even bigger than that bigger number, right? These two, they add up to the bigger number, but it didn't make a triangle. Where these two, when I added 4 and 9 together, they made a triangle. 4, 9, and 12 made a triangle. 2, 4, and 5, they make a triangle. Look at that. 2 plus 4 is bigger than 5, and they make a triangle. So our triangle inequality theorem says the two smaller sides of a triangle, when added together, must be larger than the third side. Okay, so which of these would create a triangle? Use the triangle inequality theorem and put your answer down on the right side of your screen. All right, so if you look, when we add them together, notice none of them are bigger than that third side. 1 plus 3 is 4, not bigger than 7. 6 plus 9 is 15, not bigger than 20. 2 plus 6 is equal to 8, it's not bigger than 8. So none of these make a triangle because those two sides, when I add them together, they don't make that third side. Okay, we can also use the triangle inequality theorem to find the third side. Okay, if we take our two numbers that we are given and we add them together, and then we take our two numbers and we subtract them, the range that our third side could be is any number in between those. Okay, we'll say that because if I put 2 here as my third side, remember the triangle inequality theorem. The two smaller sides have to equal bigger than the third. Okay, so 2 doesn't work, but any number between 2 and 8 would work. All right, same thing. Second, we add them together. And we subtract them to get our range. So any number between 5 and 13 would get us our number, or would get us a triangle. Okay, now you do the third one. What would it be? All right, if you said any number between 13 and 17, you are right. 232 then looks at the Pythagorean Theorem. So this should be review for you guys. You should know what the Pythagorean is and how to use it. A little bit of review. Remember, for the Pythagorean Theorem, your legs are A and B. The hypotenuse is C. Remember, the hypotenuse is always across from the right angle. Okay, the legs are the two sides that make the right angle. So when we set up our Pythagorean Theorem problems, A and B are always the legs, C is always the hypotenuse. All right, so here's our examples. First one here, remember A and B are always the legs, C is the hypotenuse. So I'm going to set up 5 squared plus 4 squared equal to C or X squared. A squared plus B squared equals C squared. Okay, so 5 squared is 25. 4 squared is 16. Equal to C squared. Add 25 and 16 to get 41. Remember, that's equal to C squared, so now we have to take the square root on both sides. And C is equal to approximately 6.4-ish. Okay, so that's your first way. Second way, notice how now our variable is on a leg. Still A and B, hypotenuse is always C. Okay, so A squared plus B squared equals C squared. Right, so we get Y squared plus 49 equals 121. Remember that squared just means 7 times 7 or 11 times 11. Get that 49 over, subtract it. So 121 minus the 49 gets us 72. And then we're going to take the square root of 72 to get us 8.5. All right, now it's your turn. So use the examples above to help you find X and Y on the examples below. So you should have gotten 10 and 5 after that Pythagorean theorem. All right, the rest of the hour we'll be working on the 231, 232 homework.